So here we have an example microservices application for an online shop, and we need to deploy it into the cluster. In this case, either developers will give that task to a separate DevOps engineer team, or developers themselves are responsible for deploying it in the cluster. In both cases, let's see how the flow happens going through the deployment process step by step. First of all, this is the code repository for the microservices, where all microservices are in the same repository instead of each one having its own separate Git repository. And in the source folder, we see the list of services we need to deploy. And this is actually an official microservices demo project from Google, which I have just forked in my GitHub account. So this is the clone or forked repository that we're gonna work with. So the first thing to understand here is that we don't actually have to see inside the code of those microservices and be able to understand what the code actually does and what these applications are actually doing. So we don't actually need the knowledge of code for those microservices to be able to deploy it. And that is actually a very important point or separation between what you need to know about microservices as a DevOps engineer. So instead of looking into the code and analyzing what the microservices do, we need a couple of key information. First of all, it's good to understand what microservices we're deploying generally, and how these microservices connect to each other, and whether these microservices actually need any third-party services or databases. As you learned previously, microservices talk to each other using a message broker. So this would be a message broker service, or these microservices might need a database where they persist all the data. So we need to know what these microservices actually depend on. Another important information would be which one of those microservices is accessible externally. So basically, which one is the entry point service getting all the requests from the browser first. So this is going to be the front-end service. And using all this information about how the microservices talk to each other, what other services they depend on, and which is the entry point microservice, we can actually create this connection graph and visualize all this stuff. And as a DevOps engineer, you will get this information from the developers because obviously developers know how their microservices work and communicate with each other. So in case of our specific microservice application, let's say that developers tell us that this is the connection between the microservices. We have email service, we have checkout service, payment, product catalog, etc. because this is an online shop, so we have all these components that an online shop needs. And we also have this front-end microservice, which is the entry point. This is actually the one that gets all the requests from the browser, which then basically forwards that request to one of those other microservices. Developers also tell us that cart service microservice actually needs Redis to store some data, right? So whenever a user basically puts some products into a shopping cart, those data will be stored right here. And Redis is actually a message broker, but also a memory database. So in this case, this will actually serve as a temporary database or memory database for all the cart or shopping cart information. So we need that service also in the cluster. And developers also tell us that one of the microservices, which is load generator, is actually optional, so we don't have to deploy that into the cluster. It only serves a purpose to basically test the load on our application. It just sends a bunch of requests to the front end to check that the application can perform under a load. So it's actually a testing microservice, so we don't have to actually deploy that into the cluster. So we have all this information, we have the graph of how these microservices connect to each other. So which one is talking to which microservice, and visualizing this will actually give us a pretty good understanding of the application that we're deploying. As a second step, obviously we need to know the image names for each microservice and what environment variables each microservice expects, because we have to provide the values to those environment variables. We also need to know on which port each service starts, because we're going to have to define that in the configuration files for deployment, but also for a service to be able to basically connect to the application inside the pod. And finally, developers also tell us that a single developers team is actually developing all the services. So we decide that all the microservices will get deployed into the same namespace. So now let's start creating deployment and service configuration files for each microservice and their dependent services. So to start off with, I have a config.yaml file, which is a template containing minimal information about a deployment and a service for each of the microservice applications. So we have a deployment, which has the name of the microservice that this deployment creates. Then we have the container definition with the image of that microservice, the port where the microservice starts, and then we have the service for that specific microservice with its corresponding name, service port, and the target port of the microservice itself. So basically this is going to be a main skeleton, like the minimum required YAML file for deployment and service components for our microservices. And we're going to need that for each one of our microservices. And since we're deploying 10 microservices plus Redis, we're going to have this exact configuration with deployment and service 11 times in this config.yaml file. And we can actually check that by searching. So we have kind deployment 11 times here. Awesome. And now we just need to basically just fill in those information that we need. Let's start with the first microservice, which is email service. And we're just going to call it email service, as is the name. So email service is the deployment name, as well as the service, and also of the pod. In the case of the pod, we're going to give it a label, app email service, and we're going to use that label basically of the pod to assign it to the deployment using match labels, selector, as well as to the service. So using this label, app email service, and selectors here and here, we're basically grouping together the email service pods with the deployment and its service. So they all belong to each other. Awesome. Let's also give the container name. Let's actually call each container a service, something generic. And we're going to set the image URL to what the developers provided us with. Or, of course, if we were the ones that set up the CI/CD pipeline for the microservice applications, then we would know the image name ourselves. And in our case, this is the image URL, which in this case actually is hosted on Google's container registry itself, because as I said, this is a project from Google itself. So that's where we're getting the email service microservice. And I'm actually using the latest version of this image, which is specified at the end here as version 0.8.0. If we go ahead and check Google's repository page and then check releases, we can see that this is the most up-to-date version. It's important to note here that you need to specify the version number. So you cannot just put the image name on its own and expect to download the latest version of the image like some of the other images we have worked with. Of course, for your own project, you're going to have an internal repository where you're going to store your Docker images. And we also need to specify a container port where the application inside the container will start. So again, we have information from the developers that email service starts on port 8080. And that's also going to be the target port, right? Where the service can forward the request to the pod or the application inside the pod. And the service port itself, which can be the same or it can actually be different. In our case, let's actually make it different and specify 5000, right? So now email service will be accessible with this name, with this service name on this service port. So the basic information about the email service is done. However, this microservice also expects an environment variable called port, and we're going to need to set that as well. And in containers, as you already know, you define environment variables using env attribute, and then basically you have name of the environment variable. In our case, it's going to be port because that's the environment variable that application expects. And we're going to have to provide its value, which in our case, it's 8080 because that's where the application should start. And that is the email service configuration. We have defined the image name, we have defined the labels and selectors and names of service and deployment, as well as container port and service ports, and the required environment variable which the application expects. Awesome. So let's move on to the next microservice, which is recommendation service. Again, deployment name, service name, and the name of the pod as a label. And we want to match all the pods with this label, right? With app recommendation service label, as well as reference all the pods in a service which have a label app recommendation service. So again, we group this service and this pod and the deployment together using labels and label selectors. And now let's set the container name, let's call it service as well, the image, which is the same container registry with the name of the microservice, and the recommendation service should also start on port 8080. So that's going to be the target port in the service. And in this case, we can give the service port itself the same 8080 port. As I said, the service port could be the same as the target port of the container, or it could be different. And finally, this microservice also has required environment variables. One of them is port. So every microservice basically expects this port environment variable value, which we're going to set to 8080. That's the port. And as we also saw from the microservices connection diagram or graph, recommendation service actually talks to the product catalog service. So we need to tell the recommendation service basically the endpoint or the service name of the product catalog service where it can connect to it. And the environment variable name that it expects is product catalog service address, like this. So that's exactly the name of the environment variable that the application expects. And we're going to provide its value, which, as I said, is going to be the name or the service name of the product catalog service that we're going to need to create. So I'm going to leave that at unknown right now. And let's actually, as the next service, create the product catalog service. So again, deployment name, service name, pod label, and selector of deployment and selector of service. We call the container service. We have the image of that microservice from the same container repository. And this microservice should start on port 3550. So that's going to be the target port and the service port. So very often we actually set the service port to the same value as the target port for simplicity. So we're going to leave that at same values. And finally, the environment variable port that every microservice expects. Like that. So now we can actually set this value here because we know that product catalog application is accessible using its service called product catalog service. and the port of its service again, which is this one right here, right? So the port of the service, not the container itself. So that's basically the product catalog service endpoint where the recommendation service can talk to the product catalog service. Awesome. Moving on to the next microservice, we have a payment service. And the image, and this one actually starts on 50,051. And we're going to set that as target port and the service port as well. And set the environment port value like this. And payment service doesn't itself talk to any other services, so we don't need any endpoints here, no other environment variables. And moving on to the next one, we have the currency service. The container port is 7000. So that's going to be the target port and the service port, and the value of the port environment variable. No other configuration needed. Moving on to the shipping service. The shipping service also starts at port 50,051, and there you go. So the shipping service is configured, and the next one is add service. We have the image configured, and the container starts on port 9555. So that's our target port and the service port. And our environment variable with the port value. So we're almost there. Next one is the cart service. Which starts on port 7070. And cart service is also the one that is connecting to Redis to save the shopping cart information. So we're going to have another environment variable here, which is going to be Redis address. So here we need to define the Redis service endpoint, so the cart service knows how to connect to it. And again, let's leave it unknown before we create the Redis service. And let's actually do that right as the next step. And let's call it Redis cart, because it's Redis specifically or only for the cart service. So we can call it like this. The container is going to be Redis, and we're going to have Redis Alpine image, which is available on Docker Hub, right? So this is the official Redis image, and Redis container starts on port 6379. And so that's going to be the target port, and we can set it as a service port as well. And now we can actually set the Redis endpoint value in cart service here. So it's going to be the service name and service port. And because actually these services are all going to be deployed in the same namespace, here we only need to specify the name of the service and the port, right? Because again, they are in the same namespace. If the service was in another namespace, then we would have to specify service name and namespace name. Great, so we have Redis defined as well, and we're not specifying any environment variables. However, as I mentioned, we need to provide a volume for our Redis application, because Redis will persist its data in memory. So we're going to provide a volume for that. Now, you learned in the volumes lecture that volumes are usually used to persist data long term. But we also have volume type to persist data temporarily in a memory. And that volume type is called empty dir or empty directory. And as the name suggests, actually, empty directory starts as an empty directory when it's created. And empty directory volume gets created when a pod that references that empty directory volume starts on a node. And this empty directory volume will then exist as long as that pod is running on that specific node. So if the pod dies and gets rescheduled on another node, all the data in the empty directory will be deleted permanently. So we'll start with an empty, fresh state again on another node. But note that if the container inside the pod crashes and not the pod itself, that doesn't actually remove the empty directory volume content or data. It will still be there when the container restarts. So as I said, we're going to use this volume type for Redis to store data temporarily in memory. And now let's see how to define that volume. It's actually pretty easy. We actually define it just like any other volumes with the same syntax, which you already know from the previous lecture. So we have the volumes attribute on the container's level, meaning this is actually specification of the pod, not the container. So here we have the list of volumes that we are mounting into the pod. In our case, let's call this Redis data. And the type of the volume is empty dir. And the value is just empty curly braces. That's how easy it is to define an empty dir volume in the pod. Basically, that's the whole syntax, right? You don't have to create anything before. It gets automatically created when the pod gets created. And now this empty dir volume that we define here needs to be mounted into the container. And we do that using volume mounts attribute, which again, you learned already. And in volume mounts, we have name of the volume that we're mounting, which is Redis data, and the path inside the container, actually called mount path. So that's the path inside the container where we're mounting that volume into. So in our case, that's going to be /data. That's where Redis will store the temporary data. And that's it. Basically, that's how easy it is to configure and mount the volume, especially a simple volume like empty dir. And our Redis application is also configured. Moving on, the next microservice is checkout service, which is going to start on port 5050. So let's define that as a target port and service port. And let's define the port value, which is 5050. And let's actually take a look at checkout service in the connection graph of the microservices. And right here, you actually see that checkout service connects to and talks to many other microservices. So it talks to the product catalog service, it talks to the shipping service, payment service, email service, currency, and card services. So it basically talks to almost every other service. And that means that for all those other microservices that checkout service connects to, we have to tell the checkout service the endpoints of each microservice so that it can connect to them. So I'm going to go ahead and add each of these different services here using the same format. So the service name followed by the value, which includes the service ports we have defined for each individual microservice already. So we're going to basically just define those endpoints right here as environment variables, one by one. And again, these are going to be the exact environment variable names that the application already expects. So we have to specify them like this. So this is not something that we think of here. It's what application code actually expects, but we can define any values for it. So product catalog service, let's actually look that up. It's right here, starts on port 3550. Then we have the shipping service address, which is shipping service port 50,051. We have the payment service address, which is available at payment service name, the same port as this one here. And there you go. So all the endpoints for all the microservices are defined using the service name of that microservice and the port where service is accessible. And at this point, I'm going to add some final environment variables to two of the services here before we move on to the front end. I know from looking at the microservice documentation that two of the services are trying to initiate a profiler when they start up. And by setting these environment variables, we tell the application to ignore the profiler service as we don't have them in the cluster. So I'm going to look for the payment service first and add a new environment variable. Here you see this is going to disable the profiler service. And let's actually copy this now and paste it to the currency service, which is going to need the same environment variable, add it to it so we can run our application successfully. Okay, awesome. Now finally, we have our final microservice, the front end. And we can actually call this front end, just like the name of the microservice. As we said, this is the microservice that gets all the external requests first and then basically distributes them among other microservices. It starts on port 8080. And we can define the service port on 80. And again, as we saw, front-end microservice talks to all these other microservices, as I said, to basically distribute the request that it gets to whoever is responsible for that request. So we need to set the endpoints of all those microservices as environment variables. First, I'm going to add the port environment variable, just like all the other services. So this is going to be port 8080. And now I can add the microservice endpoints here like this. So this will configure the front-end microservice and its corresponding internal service, cluster IP service basically. However, we said that front-end microservice has to be available or accessible externally from the browser because that's the entry point basically of the microservice application. So we need to create an external service for our front-end microservice instead of the cluster IP type of service. And one of the external service types, as you learned already, is node port, for example. And node port service type actually needs the third port attribute here, node port. And we can set its value to 30,007. So this will give us an external service for front-end microservice, while the rest of them have cluster IP or internal services, which are not directly accessible from outside. Awesome. So we have our configuration file ready. All the services are configured, all the attributes are set. Now let's actually quickly spin up a Kubernetes cluster so that we can deploy our microservice application and then see that we can actually access it from the browser. So I'm in my Linode account where I'm going to quickly spin up a Kubernetes cluster. Online shop, microservices. So I'll choose the region closest to me, and then we're going to add 3 small nodes running on a shared CPU here. We don't need to add HA or high availability to our control plane. So I will select no and then create cluster. So our cluster is ready. Let's actually download this kubeconfig file so that we can connect to the cluster. Now, before we use that kubeconfig file that we downloaded, we actually have to set its permissions to more stricter permissions, because this file actually contains credentials to our Kubernetes cluster. So we want only limited permissions on that file. And also note that we need to securely store this file and not basically share it around. For some tools, like the latest Helm version, you actually get a warning if you're using a kubeconfig file that has too much permissions or too broad permissions. So we're going to do that as a first step, always when we have kubeconfig file, as a security best practice. And that is setting permission only for my user. So as you learned in the Linux module, we basically remove the permission for the group and for anybody else. So we just give ourselves read-write permission. We could also give us just the read permission. This will work as well. And the file name and execute. And now, if we check it, we should have a read-only permission on that file as a user or owner of the file. Everybody else has no permissions to this file. And now we can use it. So I'm going to export kubeconfig variable to point to the online shop microservices config file from Linode. And now let's actually test. So we're connected to the LKE cluster. And now let's actually deploy our microservices into that cluster. But instead of deploying everything in the default namespace, let's actually create a namespace called microservices. And now we can actually deploy our microservices into that namespace by specifying an option -n and the name of the namespace. And let's execute, and we should see all the deployments and services we defined. And here you'll see deployment and service components for each microservice created. So now let's actually do get pod in the microservices namespace. And there you go. All our microservices are running. And let's check our services. And there you go. For all microservices, the internal cluster IP services got created, except for frontend, which is actually accessible from outside, from the browser, on port 30,007. So let's actually verify that our application is working by accessing it from the browser. So we need the IP address of the node. So node port service basically opens this specific port number on all the worker nodes. So basically all these 3 nodes with these IP addresses should allow us to access the application on port 30,007. And let's check. And there you go. This is our online shop or online boutique application, and it actually looks fine. We can also browse around, we can do stuff like add to cart, etc. Place order. So basically everything works fine. All the microservices are talking to each other and all the features are working.